You're working on an important configuration or project file, making changes, improving things day by day. But after a few edits, you realize you actually need the version you had a few days ago. The problem is, there's no simple undo for that. That's where TrueNAS Snapshots come in. They let you roll your entire dataset back in time, exactly to the state it was in, before any unwanted changes. In this video, I'll show you how to set up snapshots in TrueNAS, take manual restore points, recover previous versions of your data, and even automate the whole process so your files are always protected. If you're already using TrueNAS and haven't set up snapshots yet, this is one of the most important features you should enable. It can save your data from accidental edits, corruption, or even ransomware. And it doesn't take up any extra space. If you're new here and want to follow the complete TrueNAS setup journey, you can find the full playlist linked in the I button above. By the end, you'll understand why snapshots are one of the most powerful and space-efficient ways to keep your TrueNAS data safe. Let's get started. To see how snapshots actually work, I'm setting up a small demo environment. In the TrueNAS dashboard, I'll open the Dataset section and select the parent dataset. From here, I'll add a new dataset and name it Document. To make the process quicker, I'll use the SMB preset, which automatically prepares it for sharing over the network. I'll keep the Create SMB Share option checked and then click Save. This creates a new dataset called Documents and shares it over SMB. But before mapping it, I need to set the correct permissions. Under the Permissions tab, I'll click Edit, change both the owner and group to my account, and check the apply boxes under both the fields. Since the built-in users and built-in administrator entries are not needed for this demo, I'll remove them to keep things simple. I'll also give the group full control. Once done, I'll save the access control list. Now everything is ready on the TrueNAS side. I'll move to my Windows machine and map this new share. It should connect right away without any issues. Now that our share is mapped, anything we drop into this network drive is actually being stored on TrueNAS. If we set up TrueNAS to take snapshots of this dataset, every single thing stored inside it will be safely captured at that exact moment in time. Let's see how that works. I'm going to create a quick test file here and name it demo.txt. Let's open it and type something simple like, "This is the original version." Now I'll save it and close the file. So this is our starting point, the version we want to protect. To capture this exact state, we'll take our first snapshot. Let's switch back to TrueNAS. We're already on the Datasets page, and our Documents dataset is selected. Up on the top right, under the Data Protection section, there's a button called Create Snapshot. Let's click that. You'll see the dataset name is already filled in, and TrueNAS automatically suggests a name with a timestamp. I'll change that to something simple like 1_snapshot. We don't need a naming schema since we're doing this manually, and we'll talk about the recursive option later. Once that's done, just click Save. You'll get a quick notification saying the snapshot was added successfully. If you check under the Data Protection section now, you'll see one snapshot listed for this dataset. Let's click on Manage Snapshots to open it. Here you can see our snapshot with the name we gave it. Since we came from the dataset view, TrueNAS automatically filters the list to show snapshots for this dataset only. If we expand it, we can see a few more details: when it was created, how much space it's using, and how much data it's referencing. Now, here's something really interesting. The reference size shows the total size of the dataset at the time this snapshot was taken. But that doesn't mean the snapshot itself is using that much space. It's simply pointing to the data that already exists. The used size tells us how much extra space this snapshot is currently taking up. And since we just created it, that number is showing is not applicable, because snapshots only start using space when files change later on. Since snapshots in TrueNAS are incremental, they only store the data that has changed since the last snapshot. That means they take up very little extra space, no matter how big your dataset is. To understand this better, let's go back to our File Explorer and open the demo.txt file again. I'll add a new line here, right after the first one, then save and close it. So we've made a small change, just a single line of text. Now let's switch back to TrueNAS and capture another snapshot of this dataset. I'll name this one 2_snapshot and save it. Once it's created, you can see the snapshot count increase to 2. Now let's go to Manage Snapshots to take a look. Here we can see both snapshots are listed, first one and the new one we just took. Even though these represent two different versions of the dataset, they don't actually consume space like two separate backups. If we expand them, you'll notice the reference size is still the same for both. That's because it represents the total size of the dataset at the time each snapshot was captured. The use value, on the other hand, shows how much actual disk space each snapshot is taking up. And if you look closely, the first snapshot, 1_snapshot, now shows about 56 kilobytes of use space. That 56 kilobytes isn't a full copy of your dataset, it's just the tiny bit of data that changed since the snapshot was created. In our case, we only modified one line in a text file, which is less than a kilobyte, but the system also tracks metadata and respects a minimum block size, so that's why we see a bit more. If you try this with larger files, you'll notice the use space won't match the full file size. It'll only reflect the changes that were actually made. Now let's see how these snapshots actually protect our data. We already have two snapshots created. So let's switch back to our File Explorer and open the demo.txt file again. Now imagine this file got corrupted, or maybe someone accidentally modified its content. To simulate that, I'll replace both lines and type something like accidental modification of this file. Then I'll save and close it. Let's open it once again just to be sure. And yes, the file is modified. So now the current version of our file is completely different from what we had in our snapshots. Let's head back to TrueNAS. Here we can see our two snapshots, one captured when we had the first line, and another when we added the second line. But now that we've replaced everything, there's no snapshot yet for this version. I'll refresh the page so that the used size value updates properly. You'll notice that since we made changes after taking our snapshots, the data that was removed is still preserved in the snapshot. Right now it's showing around 56 kilobytes, which happens because of the minimum block size. Our file is much smaller than that, but what's important to understand is that this use size doesn't represent the full dataset. It only accounts for the data blocks that were modified or deleted. So if we want to recover our last good version, all we need to do is roll back to our previous snapshot. To do that, click on the Rollback button next to the snapshot you want to restore. TrueNAS will show a confirmation pop-up. This step is there to protect your data, especially if you're rolling back a parent dataset that has child datasets inside it, or if there are any newer snapshots or clones created after this one. In those cases, TrueNAS will prevent the rollback to avoid any data loss. You can click the little help icons in the pop-up if you want to understand these warnings better. But if you're sure about what you're doing, and you don't need any of these safety checks, you can choose the last option. For now, we'll keep things simple. Since our setup is straightforward, we'll stick with the default option, check the confirm box, and click Rollback. Once that's done, let's go back to our storage. At this point, the dataset has been rolled back to the exact state it was in when the second snapshot was taken. To verify that, let's head back to File Explorer and open demo.txt. And there it is, our previous data is back exactly as it was before the accidental modification. So if you ever lose or overwrite your files, you can easily recover them using Rollback. The only thing to remember is that Rollback restores the entire dataset to that point in time. You can't roll back just a single file. It applies to everything in that dataset. Now, what if you only want an older version of a single file, or maybe just a small part of it? Rolling back would restore the entire dataset, and that's not always ideal because it changes everything inside it. So in that case, we have another solution. When there are multiple files inside the same dataset, the process is quite simple. We can just clone the snapshot and copy the required file back from that clone. But let's look at a slightly more complex situation. Let me show you how it works using this file as an example. I'll replace the second line with a new one. In this line, I'll type something like final version before rolling back to the first snapshot. For now, we're not rolling back, we're just making a few changes to this file. I have replaced the second line with a new one. Now imagine that after a few days, you realize you need the previous line that was there before. We're just doing this with one sentence for simplicity, but in real life, I've faced similar situations with sections of code I had written earlier and then accidentally messed up later. I will save and close this file. Let's quickly check again to make sure it's updated. Yes, the changes are saved. Now let's switch back to TrueNAS. Here, I'll capture another snapshot of the dataset at this stage. Let's start with 3, and then name it as Safety Restore Point. You can see it's now showing a total of 3 snapshots. If we click on Manage Snapshots, all 3 appear here, including the new Safety Restore Point we just created. When you have automatic snapshots running, you'll usually see many of them listed by date and time. Once you remember roughly when you made that version of the file or script, you can easily spot it here. In our case, it's in the to_ snapshot. If we expand that snapshot, you'll find the option called Clone to New Dataset. What this does is it doesn't touch your current dataset, it simply creates a separate dataset that's a clone of the snapshot. When you click on it, TrueNAS will ask you to name the new dataset. There's a default name, but you can rename it or even change its path if you'd like. I'll name it Docs and click Clone. Now let's head back to Datasets. Here you can see the clone dataset listed. And if you look closely, it's pointing to the exact same snapshot as the original dataset, which is why its size currently shows as 0 bytes. So to access this dataset, we'll share it over SMB. I'll select this new clone dataset and click on Create SMB Share. The dataset name is already filled in, so we'll just leave that as it is. For the purpose, I'll choose Multi-Protocol Shares, and then hit Save. Since we just made some changes, TrueNAS will ask to restart the SMB service. Let's go ahead and click on Restart Service. Now before we open this from Windows, we need to set up the ACL permissions. TrueNAS automatically shows a prompt for that, so I'll just click on Configure. You'll notice the access control list looks a little different here, but that's fine. We don't need to change anything. So I'll simply hit Save Access Control List. Now let's switch over to Windows File Explorer and map a network drive to this new Docs SMB share. And it's connected. You can see our demo.txt file right here. If I open it, this one has the previous version, the one with the second line we had before. Let me open the current version side by side too. So now we've got both versions, our current dataset and the older cloned one. This makes it super easy to restore or copy back anything we might have lost. Once we're done, we can disconnect this network drive and delete the clone dataset. But before that, let's head back to TrueNAS. The clone dataset is already selected, and you'll see an option here called Promote. When you click on Promote, this clone dataset becomes the main one, and the original becomes its dependent. If you haven't made any changes yet, you can still switch them back later. But once either one is modified, the promotion becomes permanent. For now, I'll just promote our documents dataset again. Now I'll go ahead and delete this clone dataset. There's one more thing you should know when it comes to rollbacks. Let's go back to Manage Snapshots. I'll expand our very first snapshot here and try rolling back to it. Now notice we have 2 other snapshots that were taken after this one. If I try to roll back using the first option, it'll show an error because those newer snapshots exist. So instead, I'll select the second option and proceed with the rollback. And the dataset rollback was successful. Let's quickly switch back to File Explorer and check the file again. We're back to our original version, just like it was at the very beginning. But if we check TrueNAS, all the snapshots that were captured after this one are now gone. I'll also delete this old snapshot to keep things clean. Now let's move on and see how we can automate this entire process, so TrueNAS takes snapshots automatically at regular intervals without you having to do it manually every time. If we want to set up automatic snapshots for our documents dataset, we first need to open the Data Protection tab. Here, you'll find a section called Periodic Snapshot Tasks. To create one, just click on the Add button. Now, the first thing we need to do is choose which dataset we want to capture snapshots for. In our case, that's the documents dataset. There's also an exclude option here. You can use it if you want to skip snapshots for any child dataset under this one. If you're not sure how it works, you can always check the Help button for more details. Next, we have the recursive option. Normally, a snapshot task only captures the parent dataset, and that includes its child datasets together as one snapshot. But if you enable recursive, it will take separate snapshots for each child dataset as well. This can be really useful when you're cloning a dataset or restoring just a single file from a child dataset, but still want to manage them through one parent snapshot task. That's actually how I usually back up my system. In this case, though, since our documents dataset doesn't have any child datasets, we'll keep recursive unchecked. Next, we can set the snapshot lifetime. Remember, snapshots take up space for deleted or modified files over time. So this lifetime setting helps the system automatically remove older snapshots. By default, it's set to 2 weeks, but you can increase it to months or even years depending on how long you want to keep them. Then comes the naming schema for your snapshots. You can use the default format or check the help icon to see the different naming options you can use. Now let's move to the schedule section. This is where we decide when the snapshot should be taken. You can stick to the default choices like hourly, daily, weekly, or monthly. But if you click on Create Custom Schedule, you'll see there's a lot more flexibility. On this screen, the right side gives you a live preview of when snapshots will be taken, and the left side is where you configure the timing. We'll look at those fields in a bit. Right now, it's set to hourly by default. You can see that at the top, every hour is listed. In the calendar, all the dates are highlighted, and just below, you can see how the naming convention is set a new snapshot every hour. Now, if you switch to daily, notice how everything updates. At the top, it shows the exact time the snapshot will be captured. On the calendar, all dates are highlighted except today and yesterday, since that time has already passed. And below, you'll see each snapshot listed with a time set to midnight for every day. It's the same logic for weekly, where only Mondays are highlighted by default, and for monthly, the first of each month is marked. Since November 1st is already passed, December 1st is the next scheduled one. You can, of course, customize this however you like. Choose any day, hour, or minute. The first field is for minutes, the second is for hours, the third lets you pick days of the month, the fourth is for weekdays, and the fifth one is for months. This level of control lets you decide exactly when and how often TrueNAS should capture your snapshots, so your data is always protected automatically. Now we can set the exact times and days when we want TrueNAS to take automatic snapshots. Let's first switch it back to daily, so it's easier to understand. If you notice, both the minute and hour values are set to 0, and here too, the first and second digits are 0. That means the snapshot will be taken exactly at 12 a.m. You can also confirm that by checking the text below. It clearly says at 12 a.m. These automatic snapshot naming previews are really helpful because they show exactly how and when each snapshot will be created. Now, to set a specific hour and minute, we can simply enter numbers from 0 to 23 for the hour and 0 to 59 for the minute. That way, TrueNAS will take a snapshot at that exact time every single day. But what if you want a snapshot every hour? That's easy. Just set the hour value to an asterisk. Now you can see the pattern has changed. At the top, the second digit shows asterisk, and below it says every hour. If you want to go even more frequent, like every minute, change the minute field to star. Now it says every minute, and if you look at the file names, each snapshot is listed for every minute from now. But maybe you don't want it to run that often. In that case, we can use a slash followed by a number to create intervals. For example, setting it to /5 will take a snapshot every 5 minutes, and you can see the timestamps below instantly update to show that pattern. If we change it to /10, it'll take one every 10 minutes. You can even apply this to the hour field. So if we type /2, it means snapshots will be captured every 10 minutes, but only during even hours. And you can confirm that in the naming list, where only even hours are selected. We can also make it run every 30 minutes, or apply similar patterns to days and weekdays. For weekdays, you can even pick specific days by checking these boxes. And the same goes for months too. So with this setup, you can schedule snapshots exactly the way you want. By the way, /1 works just like asterisk, meaning it runs every minute. Now let me show you another cool feature. I'll set this to take snapshots every minute for now, and click Done. Right below, you'll see an option called Allow Empty Snapshots. This means TrueNAS will still take a snapshot even if nothing in the dataset has changed. Personally, I prefer to keep this off because I only want snapshots when there's an actual change. Next, there's an option to enable or disable this task. If you ever need to pause it temporarily, you can just turn it off instead of deleting it completely. For now, we'll keep it enabled and click Save. You'll see the task is now showing as pending. Let's wait for it to capture the first snapshot. After refreshing the page, it now says Finished. If we check the Snapshot section, you'll see one snapshot has been automatically created. Now let's wait another minute. Notice that no new snapshot was taken because there were no changes in the dataset. Let's test that. I'll open File Explorer on Windows, add a line to our test file. Save it and close it. Now back in TrueNAS, after waiting one more minute, you'll see another snapshot has appeared, this one captured right after the change was made. If you expand these snapshots, it even shows when each one will be deleted automatically. And if you ever want to keep a snapshot permanently, just check the hold option. That will prevent it from being deleted during cleanup. So that's how we can protect our data in TrueNAS using snapshots. If you run into any issues, you can always join our Discord server. You'll find the link in the description. Now that you've set up snapshots inside TrueNAS, you can check out the next video where we'll cover another important topic. If this video helped you out, let me know in the comments below. And don't forget to give it a like. And of course, don't forget to subscribe for more tutorials just like this one. Thanks for watching. See you in the next one.